This is session 9.2, Statistical Process Control, which is part of your Basics e-learning suite. This session is brought to you by MGCM. Now, before we get into statistical process control, let us understand a little bit about variation, or in other words, why we care about variation. Variation exists in all process, whether they are personal process, such as getting to work every day, or fixing dinner, or business process, such as your payment cycle, your order-to-cash cycle, or procure-to-pay cycle. A fundamental principle of process improvement is the measurement, reduction, and control of variation. There are two types of variation. The first one is called the common cause variation that exists inherently in the process. We cannot pinpoint why there is variation within the process. Some even refer to it as random variation. And the other one is called special cause variation, that is, factors that can be singled out as causes of variation. Although our customers may accept some variation, when variation is too extreme, our customers will be dissatisfied. So let us look at control charts. What are control charts? Control charts are a tool to track process variation. There are many types of control charts that can be made use of. The type of control chart chosen depends on the type of data that is measured. For example, whether it is discrete data or countable data, or continuous data or measurable data. The common type of control chart is the X-bar, mean, and R range chart to track the center and spread of data. This is an example of control charts, where here you have the mean. So as you can see, all the points are within the upper and lower control limits, and the range, which is the highest reading minus the lowest reading for the sample of data that you are plotting. Another example of control charts, you can see the outliers, points here and here, which means there are some special cause variation that are causing your measurement to go outside the specification limits. Typically, specification limits are given by your customers. So let us look at what is statistical process control. It applies statistical techniques to monitor and adjust an operation. The goal of SPC is to have in place a process that can consistently produce products without any defects, thereby satisfying your customers every time. An SPC has two objectives. One, to select processes capable of producing the required quality products. And two, to monitor processes to ensure they continue to produce the required level of quality. Now, before we do that, we just quickly understand what is process capability. Now, process capability is a measure of process spread in relation to the upper and lower specification limit. Now, if you look at this figure, it illustrates the spread of process outputs from the mean for a manufactured product. All the dark shaded distribution, the products fall within the upper and lower specification limits and are centered around the mean. The light shaded distribution has values above and below specification limits. So which means this process that is light shaded is not in control. So things will have to be changed so the data is moved closer towards the mean and within the upper specification and lower specification limits. So what is the difference between statistical process control and product inspection? Now, SPC monitors processes against statistical control limits. SPC adds value to the customer. It spots changes in variation so that corrective action can be taken to prevent defects. Product inspection, on the other hand, assesses products against a specification. Now, the product inspection does not add value to the customer. It catches defects after they occur, more like post-mortem. It is too expensive and usually considered waste, and it may not result in correction of defect root cause. So this brings us to the end of our e-learning session on statistical process control. So a quick recap on what we have touched upon in this session. We started off with understanding what variation is about, what are the control charts and how they help track variation in the process, what is statistical process control, and we finally finished it with statistical process control versus product inspection. So this brings us to the end of our statistical process control session. I hope I've been able to shed light on SPC for you. This session is brought to you by MGCM. Thank you.